Hello everyone, today I'm going to talk about bubble sort with its time efficiency. The contents of today's presentation are Introduction to bubble sort, the logic of bubble sort, algorithm of the bubble sort, example for bubble sort, and time efficiency of bubble sort, its applications, and lastly conclusion. Introduction to bubble sort. Bubble sort is a comparison-based algorithm in which each pair of adjacent elements is compared and the elements are swapped if they are not in order. This process is repeated until the entire list is sorted. Its advantages are simplicity, easy to understand and implement, stability, maintains the relative order of equal elements, and is in-place sorting, does not require additional memory. The disadvantages of bubble sort are inefficiency, performs poorly with large data sets compared to more advanced algorithms like quicksort, merge sort, or hip sort, high number of comparisons and swaps, especially inefficient for lists that are large or completely unsorted. The logic of bubble sort is as follows. Start at the beginning of the list, compare the first two elements. If the first element is greater than the second element, then swap the elements. Move to the next pair of elements and repeat the comparison and swap if needed. Continue this process for each pair of adjacent elements to the end of the list. After each pass through the list, the largest element will be in its correct position. Repeat the entire process for the remaining elements, that is, excluding the sorted elements at the end, until no swaps are needed. The algorithm for bubble sort is as follows. Algorithm bubble sort of array. The input for algorithm is an array of orderable elements, and the output is array sorted in non-decreasing order. For I belongs to 1 to length of array do, for j which belongs to length of a, down to I plus 1 do if a of a is greater than a of j minus 1, then exchange a of I and a of n minus 1. Example of bubble sort is as follows. Let's consider the following set of elements 5, 3, 8, 4, 6. Now we need to compare the first two elements, that is 5 and 3. So here 5 is greater than 3, so the elements are swapped in the array. So that you would get the array as 3, 5, 8, 4, 6. Now if you compare the next two elements, that is 3 and there is 5 and 8. Here 5 is not greater than 8. So therefore there is no swapping of elements which takes place. So therefore the order of elements would be 3, 5, 8, 4, 6. The next step is you need to compare the elements 8 and 4 of the array. Here you need to swap the elements since 8 is greater than 4. So you would get the array of elements as 3, 5, 4, 8, 6. The next step is to compare the elements 8 and 6. Since 8 is greater than 6, then swap the elements. So therefore, the order would be 3, 4, 3, 5, 4, 6, 8. The last step is repeat step 1 to 5 until there is no swap required for the array. So therefore, the array of elements which is sorted in bubble sort is as follows 3, 5, 4, 6, 8. Coming to time efficiency of bubble sort. When a bubble sort is used already on an array already in ascending order, it requires only one pass to the entire array. This is considered the best case scenario. In practice, though, this only occurs sometimes, and a bubble sort usually necessitates n into n minus 1 by 2 swaps or comparisons to achieve a sorted array. The bubble sort algorithm's average or worst case complexity is theta of n square, as we have to pass through the array as many times as there are pairs in a provided array. Therefore, when time is a factor, there may be better options. Coming to applications of bubble sort, teaching sorting concepts. Bubble sort is often used in educational settings to introduce students to the basic concepts of sorting algorithms. Its straightforward implementation helps beginners understand how sorting works. Algorithm analysis. It serves as a simple example for the teaching algorithm analysis, helping students learn about time complexity, particularly theta of n square, and the importance of optimization in algorithm design. Simple and small data. For small databases, bubble sort can be quite effective. The overhead of more complex algorithms isn't justified for every small list. Bubble sort simplicity makes it a good choice. Few swaps required. When the data set is almost sorted, bubble sort can perform effectively as it can recognize that the list is sorted and terminate early. Coming to conclusion, in conclusion, while bubble sort has significant limitations in terms of performance, its simplicity and stability make it a useful algorithm in certain contexts, particularly for educational purposes and for small or nearly sorted datasets. While bubble sort is easy to implement, its inefficiency makes it impractical for real world applications where performance is critical. More efficient algorithms are preferred in such cases. Despite its ineffectiveness, bubble sort remains a valuable teaching tool for introducing basic concepts of algorithm design such as iteration, comparison, and swapping. Thank you.